All right, let's move on to problem number 8 as we continue our topic of inverse functions. Here, number 8, they give us a square root function, f of x equal to the square root of 4x, or 4 minus x, plus 10. And it says it's a one-to-one function. So that means graphically it would pass both the vertical and the horizontal line test. Right? And you could graph the function if you want to look at it. Now you want to check it here in a minute. We could do that. So if you want, while we have it, let's just go ahead and graph that function. We can get our calculator out. I'll pull up my TI again. Let's get a picture. Let's clear out our last example. And let's store in this function just to get a picture of this square root. So we got the square root of 4 minus x, right, plus 10. So if you graph this on a standard window, zoom 6, right? Now we can zoom out. We don't see it. So I'm going to do a Y max. Let's go 20 units. And we'll start to see there's some of our graph. So you can get a picture. So I had to increase my window. Right, there's my graph begins over here at the point 410. So we couldn't see that on the standard window. But there's a picture of your graph, which you can see has a domain of all real numbers less than or equal to 4. Right, if you were to go to your table, hit your second graph button, and you'll see what happens with what? All your values greater than 4, you don't have an output, right? You see the errors. So you can see your domain right from the graph. And that's one of the questions that comes up is what is the domain, the range of your f and f inverse functions. So let's go back to our problem here. So we want to find the inverse function, which we know that graph definitely passed both the horizontal and vertical line test. It was one-to-one. And we want to find its inverse. Now, before we begin, domain, and again, we could have found the domain algebraically. So before we even begin, right, I'm going to go ahead and look at our domain restriction. We know 4 minus x must be greater than or equal to 0, right? We can't take it even with a negative when we're talking about even roots, right? We cannot have a negative number in there. And we're talking about real number values, which is what we're looking at with domain, real number values of x. So as we solve that for x, right, we can go ahead and do our work here together. We get what? We get negative x greater than or equal to negative 4. And then as you get rid of the negative to solve for x, you multiply or divide both sides by negative. Now you got to remember that you must reverse or flip, right, the inequality symbol anytime you multiply or divide by negative. So that's our only property that's a little different, right? In solving equations, we just have to remember to flip the inequality symbol whenever multiplying or dividing by negative. So that greater than or equal to becomes a less than or equal to symbol. Negative 4 divided by negative 1 is 4. Right? Now there's our domain restriction. So again, we can find domain, right, looking at the equation. So we've been doing that all semester. So I'm going to go ahead and write that down here. Domain, all the x values that satisfy your function. X less than or equal to 4, right, which is what? Negative infinity to 4 with a bracket using interval notation. So we like interval form. But that's our domain values. All right. Now, with that said, all right, we already know what the range of our inverse function. So I want to note something we've talked about in our lecture. Right. In inverse relationships, we're swapping out the x and y variables. We're swapping out our domain and range variables. So the domain of f of x function will equal the range of the inverse function. So that implies a range, which means our y values. If you were to graph this function, which we're going to find the inverse function here in a little bit, it's going to take place on the y-axis from negative infinity to 4. So it'll be all y values less than or equal to 4. So again, you interchange x and y. You're swapping out, right, with the inverse relationship, inverse characteristics. So that's something we know before we even begin, just looking at the equation of our function. Now let's go find the inverse function. Let's go find f inverse of x. So our first step, let's just go ahead and put in the relating variable. So I'm going to replace f of x with y. So y is equal to the square root of 4 minus x plus 10. All right, that's step 1. And then step 2 is to find the inverse relationship, right? Interchange x and y. That's your second step. So your relating variables, we want to swap those out. So y becomes x, and x becomes y. And then our third step is we want to solve for y. So we want to create a function. So we got to find the inverse function. So we got to find y and get it by itself. So that implies what? If we're going to solve for y, we need to eliminate the square root. So we would need to go ahead and isolate. All right, and we'll go ahead and show our work here. And write down this equation on this next line. And then we'll go ahead and work it. So we need to go ahead and subtract 10. Right? We need to isolate the square root. That would be our first step. It's working on solving for y, which is sitting inside that square root there. So that implies x minus 10 equal the square root of 4 minus y. And then we know if we want to eliminate the square root, since we've isolated it, and that's important, make sure you've got it by itself first. We can go ahead and square both sides. All right, now that'll eliminate that square root that we're looking at. So that implies x minus 10 squared equal 4 minus y. And then what? We can get rid of the 4. So we can subtract the 4 on both sides. We're still solving for y. And with that, we give us the equation of x minus 10 squared minus 4 equal to negative y. And then our last step, right, we go ahead and divide out the negative or multiply both sides by negative 1. So we'll go ahead and do that next. So with that, what do we have now in our equation? We got negative 1 times x minus 10 squared, which is negative x minus 10 squared. Negative 1 times negative 4 is positive 4. Negative 1 times negative y is y, right, which was our goal. We solved for y. So there's what we were looking for. So this is equal to our inverse function. So we'll put in our notation. So that implies f inverse of x is equal to negative x minus 10 squared plus 4. So there's really just 3 steps, right? You've got to, all right, look at your relating variables. First step, go ahead and put in y for f of x. So replacing, I'm going to write that here at the beginning, our first step. Replace f of x with y. And then interchange x and y, what we call the inverse relationship, right? So I'll make a note of that over here on the side. The inverse relation. And then we solve for y, right? We're going to create a function of x. Once we have our equation of our inverse, we just need to get it in form of y equal, right? Y equal a function of x. So we did that. We solved for y. Had a couple of steps to do that. I'd isolate the root term where y was located. And then we had to eliminate it by, right, squaring it, using the principle of powers, squaring both sides. And with that said, now we're going to talk about the domain, right, of our inverse function. So with this function here, we want to look at our domain values. So what do we have with that? Well, if you look back, now you know if you were to graph this quadratic, you would have all real numbers. Well, you remember the graph of our square root function. Well, the range, let's go back to the range. Let's pull our calculator back up. So I want to use our range to answer our domain because it does have restrictions. Where does this graph take place, right, along the y-axis? You can see it take place from where? 10 to infinity, right? If you go back to your table, right, our minimum, our maximum value right here, 4, right, we see our minimum y value of 10, right? 410 was the starting point. And of course, these y values increase from there. So our range are all the y values. So you can see here, it's all y values greater than or equal to 10. All right, so let's go ahead and mention that. So our range, right, the y values would be all y values greater than or equal to 10. 10 to infinity, right? Y greater than or equal to 10. Well, that means our domain of our quadratic function that we've created, right? That implies our domain over here would be all x values greater than or equal to 10, or 10 to infinity. Right? So again, there's our domain, there's our range, right? Inverses. So they're opposite, x and y, interchanging them. So again, if you graph it, right, you would be restricting that quadratic function down to the values of 10 to infinity. So again, you do have some restrictions on these functions f of x when you're dealing with even root functions.